The first option is the scatter plot on the FN chart, where we are plotting the FN pairs from each iteration of the simulation. These points can be plotted semi-transparently, as shown in the example, to visually highlight the area where most of these pairs plot. Mean values are shown as the diamond for without intervention and the triangle for with intervention. It is also good practice to report the percentage of points that plot above the average annual life loss guideline and the annual probability of failure guideline. We can plot the PDF for the annual probability of failure or the average annual life loss. And we can plot the cumulative distribution function for both as well. The plot of the CDF is nice because you can read the percentiles directly from the plot. For the system response in the Big FN chart, we can report the mean and the percentiles. The Big FN chart, a curve is generated for each iteration. Each curve has equal weight. The mean is generated by taking all the points that define all the curves, dividing their probability by the number of iterations, and then combining them into one data set. This is why the mean starts outside the 95th percentile curve. It will always start at the highest life loss of all the runs. Since there's a lot of data, one way to reduce the number of points, but essentially get the same curve, is to create life loss bins and sum the probability of the ends that fall in that bin. You just need to make sure that you have enough bins to adequately define the curve. On the consequence side, box and whisker plots are often used to show the range in the estimated life loss. The ends of the box give the lower and upper quartile values, which is just a fancy way of saying the 25th and 75th percentiles. Where the box changes from blue to yellow in this example is the median or 50th percentile value. The whiskers that come off the ends extend to the minimum and maximum values. I haven't seen anyone do this just yet, but the annual probability of failure, the average annual life loss, the average annual economic cost, and the individual risk could all be portrayed using box and whisker plots. Tornado plots can be generated in at-risk and are a good way to illustrate the key components that are driving the risk estimate. In this particular plot, at-risk determines the amount of output variance attributed to each factor. The higher the contribution to the variance, the greater the impact on the output.